Alright, this should be a quick one. We're talking about similar polygons. Similar polygons, all of the angles are congruent and all of the sides are proportional. All the angles are congruent, all the sides are proportional. The symbol for similar is the top of the congruent symbol. It's called a tilde, I believe. Alright, so let's just get into an example here. We're looking at similar polygons. So example 1, trapezoid ABCD. Remember that trapezoid is a quadrilateral with one pair of parallel sides. So we know those are parallel because same side interior angles are supplementary. 90 plus 90 is 180. Plus they told us. Alright, so this trapezoid is similar to this trapezoid. List all the pairs of congruent angles. Alright, so when they label them like this, we can just go from the first letter, and that corresponds to the first letter. They're just like with triangles. So this should be pretty simple. You can go ahead and pause the video, and always try to pause and do the problems when you think you know how to do them, and then check as you go. So angle A is going to be congruent to angle P. Alright, and like this picture is fairly obvious, but sometimes it's not that easy to tell from the picture, so when they do give you the names, you would rather go by the names. So then it would be angle B and angle Q and angle C and angle R and angle D and angle S. Alright, and now we want to list the proportional sides. So I'm just going to go in order here. So I'm going to say side AB over side PQ. Alright, now if we go back to alphabetical order, actually instead of going across there, we would want to do DA or AD. AD would be alphabetically the next side. So if we do AD like this, then we're going to want to do PS. So now we would slide over to the next one there and do BC and QR. You could pause the video right now and make sure you get this last one yourself. So that would be CD and RS. And very simple, straightforward question there. Alright, so moving right along, decide whether these figures are similar. If they are, write a similarity statement. So not that easy to do. We have these angles matching here. We really need all three angles, and we need the sides to be proportional. So what we could do is set up proportions with the sides. So if we take the smallest side in this triangle and the smallest side in this triangle, we could create a proportion, ratio there. So that ratio is going to be 4 over 10.5. Now, that's a little bit awkward to look at. So what we might want to do is double both of those to get rid of that decimal. So if we double that, that would be 21. 8 over 21. Now what we can do is go to the medium, the middle side. So that's 9 and 12. And so we can put 9 over 12, and that reduces to 3/4. So immediately, right now, we can see that these two are not proportional. These two do not equal each other, and so they're not proportional. And to be similar, all the sides have to be proportional, the corresponding sides. So the small sides correspond, the medium sides correspond, but they're not. The ratios are not equal. So this is not similar. That's the symbol for similar. And we could go ahead if we wanted to and look at that third ratio. That was 12 and 18, which reduces to 2/3, and that's not equal either. But we didn't really need that. Once we found a pair that was not proportional, then we were done, basically. Okay. So highlighted test type question if we were in person. You have a photo that is 4 inches wide by 6 inches long that you want to reduce to fit a frame that is 1 inch wide. Excuse me. Okay, so when we set these up, we had one of these the other day. Start with the variable. Start with the unknown. Start with the variable. So we want to know how long the reduced photo, which would be the frame. So the question is, how long is the frame? So I'm going to put frame here and length here. I'm going to use F for that. So we have F, length, frame, and then we also have photo, frame and photo, and we have length and width. So with these word problems, proportions, similarities, it's a good idea to just set up a little chart like that. So what do we have in our chart? We have width and we have length, and we have a photo and we have a frame. So the thing we're trying to find goes here. Now I need the length of the photo. So the photo is 6 inches long. So that's going to be 6 inches there. And then the width of the frame is 1.5 inches. And the width of the photo is 4 inches. Alright. So a lot of people will have you cross multiply here. To me, that seems like kind of a wasted step. You can do that if you feel like that's better. But really what I want to do is multiply both sides by 6. I want to multiply both sides by 6 to cancel out this 6. If I cross multiply, that's going to give me 4 times f, and then I'm just going to have to divide by 4 anyway. So it seems a little wasteful. Alright, so now we have f equals this because these 6's cancel out. This is going to reduce to 3 and 2. So now we have f equals 3 times 1.5, which is 4.5 over 2. Okay, so that actually we can divide by 2 fairly easily. We could switch it to 9 over 4, but maybe not that helpful. I'm just going to divide that by 2. So 4 divided by 2 is 2, and 0.5 divided by 2 is 0.25. You can think of that as $4.50 divided by 2 would be 4.25 inches. And if we wanted a fraction, we could do that. And this is a word problem. Measurements are word problems, so we do want to have a mixed number here. We would not want to leave that as 9 over 4. And we definitely would not want to leave it with a decimal. We don't write decimals. We don't write fractions with decimals in them. So we definitely would want to switch that to 9 over 4. And then again, because it's a word problem, switch that up. So let's keep moving here. So another similar situation, except now instead of a picture and a frame, we have a picture and a wall. And it says a painting is similar to the wall which is hanging, which means all the angles are 90 degrees. Well, they don't have to be 90 degrees, but they all have to be equal, and we assume that they would be 90 degrees. It's a wall and a picture of painting. So since it says they are similar, that means that they have to be proportional. Alright, so we have a comparison of 3.2 to 8 and 6 to 15. Now actually, it says wall to painting. So whatever comes first, okay, whatever comes first goes on top. First goes on top. So if you think about the medal stand in like the Olympics or track and field, or the medal stand usually kind of goes like this, right? And this is a first gold medal, silver medal, bronze medal, and whoever's first is on top, right, of the medal stand. Same thing with sports. If you keep track of a sports team and you look in the newspaper, the Golden Knights or whatever, the Raiders, or whoever your favorite teams are, they're listed, and whoever's in first place is on top of the standings. So that's how you can remember this. Whatever they say, when they ask for a scale factor, and you need the 2 vocabulary words from this lesson are similar and scale factor. So whatever comes first goes on top. So the wall was first. So the wall needs to go on top. So that's going to be the wall over the painting because the wall was mentioned first. Okay, so that's going to be 15 over 6. Now why did I choose 15 over 6? Because 15 over 6 looks better to me than 8 over 3.2. That has a decimal in it. That seems like it would be more complicated. So I'm going to start with these two numbers over here. And then that is going to reduce to, and these are both feet, so that's probably helpful. So they'll cancel out. A scale factor is just a number. It doesn't really have units attached to it. So both of these can be divided by 3. So that's going to be 5 over 2. So the scale factor of the wall to the painting is 5 over 2. If we asked for the painting to the wall, that would be the reciprocal of that. So that would be 2 over 5. Now, there is another application of that that's a little bit different, so you want to make sure. Well, we'll wait till we get there and we'll tell you the difference. Okay, so moving right along, we're almost done here. This is a pretty short one, so that's nice to get us back into things here. 2-pager, and this says that if two polygons are similar, then the ratios of their perimeters will be similar also. That should make sense. If all, let's say these are all double. So if this is double that side, and this is double that side, and this is double that side, and this is double that side, then if we're doubling all the sides, and to get the perimeter you add up all the sides, it should make sense that we are doubling the perimeter also. So that's all this says, that the scale factors, the proportion of the sides is the same. So the proportion of sides equals the proportion of the perimeter. So that's all that's saying. Okay, so if we look at this, parallelogram is similar, find the value of y. Okay, and that's not even a question about that, so they want us to find y. So if we look at this, CD, let's find that. So CD is right there, and CD is right here. So CD is going to match up with EF. Now, it just so happens that those are kind of in the same location, but that would not have to be true necessarily. That's just a coincidence that they happen to be lined up here. It would be possible that that would be matching up with this. So it's important to check and not just assume from the photo or from the picture, drawing, whatever. Okay, now we can also look at this, and we have GF, which is over here, GF, and that's going to need to go with AD, because those are the only other numbers we have, so we are going to need those. So remember we said to whatever you're trying to find, put that first. So we're trying to find y, so put that first. Put it on top of the first fraction. Okay? The extremes. Remember, first and last are the extremes. These are the means. So y over 12, and 24 over 15. You want to go the same way both times. Okay? So here, 3 goes into both of those. So 3 goes into there 8 times, and 3 goes into here 5 times. So when we can reduce those fractions, that's a good idea. Do not, one mistake that we see sometimes is kids try to cancel across here. Never do that. Never cancel across an equal sign. That's really bad. Okay? It's really bad. Alright. Mathematically wise, anyway. Okay, so again, some people cross multiply here. I think that adds an extra step. That's more work. That's not very efficient. So what I would just do is multiply both sides by 12. And you can see that is kind of cross. That's half cross multiplying. We're going to cross multiply this way. But also, I usually don't multiply that out because I want to see if I can reduce first, but I cannot. We cannot reduce first here. So this would be 8 times 12 over 5. None of that reduces. So I'm going to go ahead and multiply this. That's going to be 80 plus 16 is 96. Now this is not a word problem, there's no units on there, so that I would just leave that as a improper fraction, and that's fine. Okay, and that kind of wraps up the new lesson, and now we're just going to review a little bit. And so this factoring is very important in Algebra 2. There's a lot of factoring and the different things that you have to do in Algebra 2, so that's why we review it a lot in our class also. So this is pretty early on. This is the first week of the second semester, so please get motivated to do things the right way to help you improve your chances as you move forward. Okay, so when we see four things here, there's two things we want to ask when we factor. Number one, is there a GCF, a greatest common factor? And number two, can we factor again? So those are the two things we want to keep in mind when we factor. Now, if there are four terms are separated by pluses and minuses, then normally that's going to be factored by grouping. Okay, so that's something we want to keep in mind. So we see four terms here, and the first thing we should notice probably is that we can factor out a 3x here. All these are divisible by 3, and all of them are divisible by x. So 3x. And then, if we did that, we would have 6x cubed minus 3x squared plus 10x minus 5. Now, normally what I would suggest is you just bring that down and put it on the answer line down here. Okay? Now, here's where the factor by grouping comes in. We're going to divide this into two groups. So we look at the first group, and what factors out of there? We can factor out 3x squared. And if we factor out a 3x squared there, we're left with 2x minus 1. 2x minus 1. I'm just going to leave this off because I already wrote down here as the answer. The problem is some students leave it off and then they forget and they don't put it on their answer, and so then they lose a point. Now, when we do factor by grouping, whatever we got in here, this should be the same. This should be the same as whatever that was. So that is also going to be 2x minus 1. And so that helps us look at this and say, what can we factor out of this to make it equal to that? And so that's going to be plus 5. Be careful with the sign. Plus 5. Also, if this turned out to be 2x minus 1, then we would have to factor a 1 out. So you do have to have a number here. And it could be a 1. So that's something to keep in mind too. And now we're pretty much done. So what do you see? What's the same? Remember, factors are multiplied. Here my factors are 6 and x cubed. So those are factors. These are terms. Terms are separated by pluses and minuses. So we're going to factor out the 2x minus 1, and that leaves us with 3x squared plus 5. Again, hopefully most of you know how to do this, and you could just pause it, do it, and then fast forward to the answer and make sure it's right. You don't have to sit here and listen to me explain how to do it over and over again if you already know how to do it, because we're about to do the same thing right now. So pause, do it, and then fast forward. Okay, so there is no GCF here because 25 and 36 don't have the same factor, and then these, there's no x or y in all of them, so that's not going to work. So we're going to do factor by grouping. So 25x squared, leaving us with x plus y. And then the second group here, that looks like we can factor out a negative 36. And remember, it should be the same, x plus y there. So now, you factor that out, that's going to be x plus y is the same in both those, and what's left over, 25x squared minus 36. Now, some of you, I would hope, I think, could have skipped this step in blue here, because you saw that we had 25x squared minus 36. So that is the difference of two squares. Hopefully you remember that. Difference of two squares. Difference of two squares. And so when we have the difference of two squares, we take the square root of both of those. That's going to be 5x minus 6 and 5x plus 6. That's a very important factoring difference of two squares. Okay? And these three questions are off of a math competition. So we'll knock these out real quick and then we'll be done. So 650 students were surveyed about their pasta preferences. The choices were lasagna, manicotti, ravioli, and spaghetti. The results in the survey are stored in the bar graph. What is the ratio? Okay, so that's why this is in Chapter 8, a ratio question. The number of students who preferred spaghetti to the number of students who preferred manicotti. So remember, what came first? The spaghetti came first. So spaghetti's right here. And that looks like 250. Spaghetti came first. And manicotti, that came second. Manicotti came second. That is over here. That's going to be 100. So those reduce there. 5 goes into both of those. And you can see that's pretty easy for a math competition. Okay. What is the sum of the two smallest prime factors of 250? So what we need to do is factor 250 and then add sum. You need to know what sum means. That means add, answer to an addition problem. So 250, so one way we could do that is with a factor tree. So 2 and 125 and then 5. I keep trying to divide 2 out as long as I can. That's an odd number, so I know that 2 is not a factor, but anything that ends in a 0 or a 5 can be divided by 5. So that's 5 and 25, and that's 5 and 5 again. So the two smallest factors, the prime factors, really it's 2 to 5, 5, 5, but the two smallest are 2 and 5. So 2 plus 5 equals 7. All right. And the last one here, a haunted house has 6 windows. In how many ways can Georgie the ghost enter the house by one window? Okay, so there's 6 different windows, so there's 6 different ways to do that. And leave by a different window. Okay, so it says a different window. So that means that the can't go in, and I don't know why a ghost would have to go through a window anyway, but ghosts are supposed, right? Can't they go through walls? But whatever, that's not important. Focus on the question. So a different window, there are 5 choices for that. So hopefully you've had, we'll do a little bit more of that at the end of the year, but when you're going to make 2 choices, you multiply the first choice, the number of ways the first choice times the number of ways the second choice. So I think we can all see that's going to be 30. Some common questions like that are lunches, like how many different meals can you have if you have a certain number of sandwiches and chips and drinks. And the other common question for that is clothes, meals and clothes. So meals and outfits, like if you have a certain number of pants and shirts and shoes, how many different outfits can you have or whatever. All right, so that's it's about that time. Get on your assignment, do that right away, and have a good day.